Your brain is quite awesome. It can process manifold things. For instance, your brain allows you to think, move, and speak. But how do we know which part of your brain is responsible for this? There are various techniques that help brain researchers to look at your brain. Some use big, strong magnets. Others use light to look at your brain. A technique that uses light is called functional near-infrared spectroscopy, or in short, fNIRS. We will call it fNIRS from now on as well. That's much easier. So let me explain how this technique works. When you are taking part in a fNIRS experiment, you will notice a machine that looks somewhat like a computer. You may find colorful plugs connected to the fNIRS machine. These plugs are sensors of the machine. Some of these sensors send light, here the red ones, and other sensors detect light, the blue ones. The plugs are often inserted into a cap. Once the measurement starts, the red sensors shine red light onto your head. This light then travels in a banana-like shape through your skin and your skull until it reaches the outer layer of your brain. Some of the light travels back to the surface of your head, where the blue sensors are. The blue sensors measure the exact amount of light that is coming back. But how can we use light to measure your brain's activity? To understand this, I will explain what happens in your brain when it is active. Just like yourself, your brain needs food and oxygen. When brain areas become active, they need even more fuel. Oxygen is carried to brain areas by a protein in your blood that is called hemoglobin. Hemoglobin is what makes your blood red. In order for oxygen to reach the active brain region quickly, blood vessels become wider. The blood flow increases. Lots of fresh blood with oxygenated hemoglobin arrives at the active brain regions. This change in oxygenated hemoglobin is what you can see with fNIRS. This is because oxygenated hemoglobin swallows or absorbs some of the light. When there is more of it, more light is swallowed on its journey through the head. Therefore, less light than the red sensors did send into your head reaches the blue sensors. Based on the difference between how much light is sent by the red sensors and received by the blue sensors, brain researchers can calculate how much oxygen a certain brain region has used. By doing that, they know which brain region is active. So, now you know what the fNIRS does. But what is your part in a fNIRS experiment? And why is that important? fNIRS devices can record almost all of your daily activities. Thereby, it supports us brain researchers to find out which brain areas are needed for each task. Often, you will be playing a game on a computer while you're wearing the fNIRS cap. The good thing about this technique is that some devices can handle movements quite well. There are also small devices that you can carry around with you in a backpack while it is recording. This makes it possible to look at your brain when you are running or when you are at school. You could even see what happens in the brains of two people at the same time. fNIRS is not harmful and is very safe. This makes fNIRS also suitable for very young children and even babies. Isn't that cool? Children who are facing difficulties, for example with hearing or attention, can also take part in a fNIRS experiment. Brain researchers are interested in understanding how and why their brains react differently in certain situations, so that they eventually know how to help these children. fNIRS might even help us to train the brains of these children to help them improve. Brain researchers can show you your brain activity live on a computer screen. You then can try to activate your brain a little more with your thoughts and imagination. So, fNIRS offers many opportunities to understand the brain. We are excited to see what else we can find out about the brain. Maybe you will join us someday. Thanks for watching.